in today's note, we are just going to be looking at a summary of all the different ways we've looked at linear relationships and how to kind of identify the different parts. We've seen it done as basically patterns, we've seen word descriptions, we've seen graphs, we've seen tables of values, and we've seen equations or rules, particularly y equals mx plus b. Regardless of what the scenario was, our rule or our equation was always in this form. We may have seen things a little bit differently, like the y and the x may have been different values, but we always had those two kind of that general form. So for example, below here we can see the same linear relationship depicted in different ways, or the 5 different ways. So we see it as a pattern, we see it as a table of values, we see the equation, we see the graph, and we see the word description. So the properties that make it easier to connect the various representations of a specific linear relationship are basically the slope and the y-intercept. So those are the two key things that are the same throughout all of them, right? And any equivalent representations of a linear relation will have identical values for the slope and the y-intercept. So it doesn't matter which relationship I look at, it's going to have the same values for slope and y-intercept. So if I go through and I look at some of these, say, let's start with the equation. The slope is the m value, so that's the 4. The b is the y-intercept, or the 2. If I go to the graph, I can see that because I can see my y-intercept there. I can see my m, or my slope, is 4, because as I go up, or as I move over a step, I go up to 6, and this is kind of a rise over run. So we run 1, we rise 4, so 4 over 1 is 4. We can see in the table of values, our b value is that initial, or 2, and we can see that as we increase, we're increasing by 4 every time we increase by 1. We can see this in the pattern as well. As we go from one to another, we're increasing by 4. So these two are increasing, and as we go again, these two are increasing. And if we were to go back a step and take away 4, we'd end up with just 2 blocks. So our initial value. And we can see it in our word description. All right, we can see it as per book, which means $4 per book, or every time I add 1 book, it's changing or increasing by 4, which we can see every time we add 1, we're increasing by 4. And we have our flat fee here, or delivery fee, or initial fee, or base fee, starting value, whatever you want to call it, is 2. So when nothing happens, or where there's no books involved, it's 2, which we can kind of see in the step pattern, or not the step pattern, the pattern. Initial stage is 2, b value is 2, y-intercepts 2, table of values, when x is 0, it's 2. So again, same values in all the representations. Below, what we're going to look at is just a summary of the different terms that we've seen throughout the first 3 lessons to represent slope, or m, and y-intercept, or b. So the general equation used to represent a linear relationship is y equals mx plus b. And remember that our m value, again, these are the 2 key things that we're going to be looking for in our equation. These are the 2 things that we need to figure out or to find anytime we need to find an equation or a rule. The m value, remember, we have our slope, represents by the letter m. We also know it as multiplier, rate of change, change in y over change in x, rise over run. You may see the change in y over the change in x sometimes depicted as triangle y over triangle x. Basically, the triangle is just representing a Greek letter delta. So you might hear or see it as delta y over delta x. That means the same thing, change in y over change in x. Our y-intercept, or our b value, remember, is represented by the letter b. It's also known as the initial value, the starting value, the constant. You may see it in word scenarios as the starting price, the base fee, the initial fee, the flat fee, something along those lines. So all those different terms represent the y-intercept. Below here, it's a look at how we find the slope and the y-intercept in each of the representations. So in those 5 different examples, how we can find the slope and the y-intercept, because those are the key things that we need to find. Because again, we mentioned that regardless of the representation, the slope and the y-intercept should be the same if they're representing the same linear relationship. So if we look at an equation, remember the slope is the value that multiplies the independent variable, or x in this case. Remember, the variables may be different, but the slope is the one that's paired up with the x. So we can see that here. The y-intercept will never have a variable with it. That's why it's called the constant. It's always going to be the number on its own. So in this case, it's the +2. So sometimes, and we've seen some examples of this before, if this was rewritten as 2 plus 4x, the multiplier is still going to be 4. And the constant, or the y-intercept, is still going to be 2. Because 2 is not being multiplied by anything, it's not attached to the variable. The 4x still is, even though it's second. So keep that in mind. In a word description, an online discount bookstore charges $4 per book and a $2 delivery fee. When we're looking for the slope, or the m value, look for a word description, or look for keywords such as per, for every, the rate, or each. And that's usually a good indicator of the slope, right? Because in this case, we're talking about $4 per book, or it's going to increase every time we have one book. Or every time we add a book, it's going to increase by 4. And if we go back to our table, we would see that. And that would indicate that our slope is 4. The y-intercept will be a one-time amount that doesn't reoccur. So it doesn't continuously get added, or it doesn't add when numbers increase. So in this case, when we look at a delivery fee, the delivery fee is a one-time amount. It does not continuously get added. You do not get charged multiple times for it, right? And that's where you'll see those terms of flat fee, base price, initial fee, things like that. So that's going to indicate that it only occurs once. It's still there, but it only occurs once. For a pattern, in a pattern, we find the slope by looking at how the pattern has changed from one step to the next. And in this pattern, we can see that we're adding 4 new tiles every time we increase a step. So every time we increase a step, we've kind of already highlighted this one, we increase by 4, and then we increase by 4 the next time. So every step we increase by 4, that's going to be my slope. To find the y-intercept, we need to find the y-intercept by considering how many tiles would be at a step 0. Right? So step 0, remember, is our initial step, or our starting step. So sometimes we may have to go back a step. So in this case, we kind of just reverse the pattern. So if we're increasing by 4 every time we increase a step, if I want to go from step 2 or step 1 back to step 0, I'd reverse it, so I'd -4. Whatever that answer is, or how many tiles or how many items there are at that step, that's my y-intercept, or that's my constant. So in this case, from going step 1 to step 0, I -4 squares, and I end up with only 2. So my y-intercept is 2. Looking at a table of values, we can find the y-intercept in the table by looking at the y value when x equals 0. So in this case, we've circled this before on previous examples, but we can see here when y equals 0, or when x equals 0, the x or the y value is 2, so our y-intercept is 2. Recall that the slope can be found by dividing. So this is where we have the change in y over the change in x. So you want to find 2 points from your tables. So again, they can be 2 points that are right beside each other, like these two are. The change in y is 4. The change in x is 1. So we divide 4 divided by 1, and that equals 4. If you wanted to as well, again, you don't have to use points that are side by side because you may not be able to find those, or the table may not give them to you. So say we're doing from 2 to 4, we're increasing by 12, and from 0 to 3, we're increasing by 3. So the change in y in this case is 12 over the change in x, which is 3. 12 divided by 3 is still 4. So either way you look at this, or regardless of which 2 points you use, you'll still get the same answer. In this case, 4. In our graph, so if we're given a graph, remember that the slope can be found by dividing change in y by change in x. So here we want to start by finding some friendly points. And so again, the friendly points we've talked about are points that fall nicely on our grid lines, or ones where we can find the exact values of. So in this case, we have 2 here, 0 and 2, and 1 and 6. It's helpful to put those into a table, even if it's just a short one with only 2 points, to help us figure this out. From there, we can easily see our change in y and our change in x, and then we can put that into our slope formula and divide, and we get our slope is equal to 4. The y-intercept, remember the y-intercept we can find by looking at where the line crosses the y-axis. So you can start at the y-axis and just go straight down until you hit your line, and that value is your y-intercept, in this case positive 2. So again, or you can just see and recognize, okay, well, it crosses right here. That's where it crosses my y-axis, so that has to be my b value. In this case, that's 2. So again, this is a summary of basically everything that we kind of looked at in this second half or over this week of how we can determine an equation or a rule for a pattern or a scenario given various pieces of information, whether it's a graph, a table of values, a pattern, a word description, or an actual equation. We should be able to find the slope and the y-intercept. And if not, again, use this summary to help you work through those steps and start to be able to identify where those pieces are.